Today's lesson is on angles and parallel lines. Please remember to take notes throughout this presentation. Okay, so what is an angle? Basically, an angle is formed when two rays, or line segments, are connected at a single point called the vertex. The difference in the direction of the two rays determines the angle's measure in degrees. So take a look at some of the angles I have down here below. What I mean by a ray or a line segment in this case, and let me pull out my laser pointer, is this line, and the other ray is this line, and they're connected together at this single point right here where my laser pointer is, called the vertex. And the difference in the direction of those two rays determines the measure of the angle. Notice how both of these angles are 45 degrees. So it doesn't matter the orientation of the angle, meaning which way it's pointing, like this one's kind of going to the left here and this one's kind of going up. It's that difference in the direction of those two rays that determine the angle measure. And over here we have what's called a protractor. A protractor is used to measure an angles in degrees. So the way that you would use it is that you would put one of the lines right along the bottom of this protractor here, and then you would look at where the other line crossed, and then you'd read off the measure in degrees. All right, so here's an angle of measure of 130. Here's a measure of an angle 120. Here's a 90-degree angle, which we also call a right angle, and it looks like how the floor meets the wall. And as you open up the second ray more, the measure of the angle gets larger. And then if you open it up all the way until it's a perfectly straight line like we have on the bottom here, we call that a straight angle. And all straight lines or straight angles have a measure of 180 degrees. Next, let's talk about what a transversal is. All right, a transversal is a line that intersects two other lines in the same plane. So take a look at the figure below. I have two lines here, A and B. They're in the same plane because they're on the same flat piece of paper, right? In this case, screen. And I'm going to cut it in half with line C here. So I'm going through both lines A and B, and since I am intersecting them, that just means crossing them. Crossing both of them, we would call line C a transversal. The next thing we're going to talk about is corresponding angles. So when we have two lines that are crossed by a transversal, here's line A and line B, and it's cut by the transversal C, the angles in the matching corners are called corresponding angles. All right, so take a look. I'm going to go ahead and label each angle with the numbers 1 through 8 in this case. So what do I mean by angles and matching corners? Well, take a look at 1 and 5. Notice how both angles 1 and angle 5 are above line C and to the left of either line A or B. So they're like in the same kind of spot relative to the transversal. So that's why we call them corresponding, because they are like the same, they correspond to each other. So they're in the same kind of position, so to speak. So 1 and 5 are called corresponding angles. But they're not the only corresponding angles in this figure. 2 and 6 are also corresponding. They're on the left side of their respective lines and on the top side or above the transversal in both cases. Do you see any other corresponding angles in this figure? Sure. 3 and 7 are called corresponding angles. They're in the same relative position relative to the transversal and their lines. And also lines 4 and 8. So in this one figure here we have 1, 2, 3, 4 pairs of corresponding angles. So remember, if they correspond, it means they're in the same relative position to each other, respective of the transversal and their lines. Alternate angles. Okay, alternate angles are two angles that are on opposite sides of the transversal. So before we talked about corresponding angles, they were in the same relative position to the transversal. Alternate angles jump across the transversal. They're on opposite sides of it. So for example, in this figure, angles 2 and 7 are alternate angles because they jump across the transversal. So they alternate across it. 4 and 5 are called alternate angles. In fact, the angles that are on the inside of these two lines are called interior angles, because notice they're on the inside, so the word interior means on the inside of something. And since they're on the inside of lines A and B, we would call them alternate interior angles. So 2 and 7 are alternate interior angles. They alternate across a line and they're inside of lines A and B. And 4 and 5 are another pair of alternate interior angles because again they're alternate across the transversal, they're on opposite sides of it, and they're on the inside of lines A and B. So how about the ones on the outside then? For examples, 1 and 8 are called alternate angles, and 3 and 6 are another pair of alternate angles. So remember, they jump across the transversal. And in this case, 1 and 8 and 3 and 6 are referred to as alternate exterior angles, because now notice that they're on the outside of the lines. So they alternate across the transversal and they're on the outside of lines A and B, so they're alternate and exterior. And there's two pair of them. 1 and 8 are alternate exterior angles, and angles 3 and 6 are alternate exterior angles. So let's go ahead and practice. Let's identify a pair of corresponding angles in this figure. So any pair of corresponding angles, and there's more than one pair. All right, so let's take a look. And in this case, we want to look at corresponding angles. Remember, correspondings are in the same relative position to the transversal. So for example, angles 2 here, first of all, the transversal is this diagonal line here, because it is intersecting these two lines. So I know it's the transversal because it's the one that's crossing both of them. And now angles 2 and 6 would be called corresponding angles. They're both to the right in this case of the transversal and above their respective lines. And they're in the same relative type position, so we say they correspond. 2 and 6. But they're not the only ones, right? 3 corresponds to 7. 1 corresponds to angle 5. Angle 4 corresponds to angle 8. How about we identify a pair of alternate interior angles? So think about what the word alternate means and think about what the word interior means. So here there's going to be two answers. There's going to be two pair. So first of all, let's go with the word interior. It means inside of something, right? Like an interior decorator decorates the inside of a house or building. All right, so in this case, what are we inside of? We're inside the two lines cut by the transversal, excuse me. So we're inside here. So I know we're talking about 4, 3, 5, or 6. Now we want to find the ones that alternate. So remember, so they're alternate, so they jump across the line. So in this case, it would be 3 and 5. So they jump across the transversal, and they're inside, so we call them alternate. And so a question, and also another pair, is 4 and 6. So there's our two pairs, right? 4 and 6 are a pair of alternate interior angles, and so is angles 3 and 5. So angles 3 and 4 here, they have another name, and we're going to learn about them next. So remember, to alternate, they jump across and they touch the other line, right? And then we'll be able to identify them easier later when I give you some more information. Before we do that, let's talk about a pair of alternate exterior angles. So again, exterior means on the outside of the two lines. So the exterior angles here are 1, 2, 8, and 7. Now we need to find the ones that alternate. a pair that alternate. So it means they're on opposite sides of the transversal. So in this case, that would be 2 and 8 are a pair of alternate exterior angles, and 1 and 7 are a pair of alternate exterior angles. Okay, so now finally we're going to talk about what a linear pair is, right? So the definition that they would give in a textbook is that a linear pair is two adjacent angles that form a straight angle or a line, right? So I like the word linear pair. So if you look at that word, the word line is right in the word linear. So a linear pair are two angles that make up a line, that make up a straight line, okay? So in this case, let's label these angles, 1, 2, 3, and 4. And we're going to find a pair of angles that together make up a straight line. And by the word adjacent in this definition, that just means right next to each other. It means they share a vertex, and they're right next to each other. So they're right next to each other, they share a vertex, and they make up a straight line. So that's what a linear pair is. So in this diagram, I have angles 1 and 2 would form a linear pair. Notice if I take this angle and add it to this angle, I get the straight line B. We could follow this around clockwise, and we could also say that then 2 and 4 form a linear pair, because again they meet this definition of being adjacent. That just means right next to each other. They share a vertex, and they make up this straight line A. Okay? That's not the only one either. We could say that angles 3 and 4 form a linear pair, because again they're right next to each other, and they make up this straight line together. And then finally we get that 1 and 3 form a linear pair, because this angle 1 and this angle 3 make up this straight line A. You might have noticed that the adjacent angles, right, when we're talking about a linear pair, always add up to 180 degrees. In a straight angle, like we saw on slide 1, there's 180 degrees. So a straight line is 180 degrees. So a linear pair will always add up to 180 degrees because they form a straight line. Next, we need to talk about what a vertical angle is. Okay, so when we have intersecting lines here we have two lines, they're crossing each other. The vertical angles are the two non-adjacent angles formed by the intersecting lines. So non-adjacent, again, is just another fancy way of saying not right next to each other. So they're not right next to each other, but they do share a vertex because we have intersecting lines. All right, so in this case, I'm going to go ahead and label these angles 1, 2, 3, and 4. And before we talked about angles that were next to each other, like 1 and 2, or 1 and 3. Now we're going to talk about the angles that are not next to each other but share a vertex. So that would be like 1 and 4, and 2 and 3. So notice like we have an X here, these intersecting lines, and they're the ones that are like across from each other. An interesting fact about vertical angles is that they have the exact same measure. Okay, so vertical angles are congruent. So they have the same angle measure. You can kind of look at the picture and notice that angle 1 looks about the same size as angle 4, meaning like if I took this angle, angle AB here, angle 1, and I flipped it over, it would lie right on top of angle 4. It'd be the same measure. So when two angles or two lines or anything in geometry have the same measure, we say that they're congruent. So if you think about the word congruent as being equal, then you're going to be safe in geometry of thinking as congruent meaning equal. In reality, in geometry, they make a small difference between those two words, equal and congruent. And you don't need to be responsible for that information right now, but since I brought it up, I guess I'll answer my own question. The slight difference is that congruent means they have the same measure, and equal means they would be the exact same angle. So that's the small difference between the two. Okay, so let's talk finally about angles and parallel lines. All right? If two parallel lines are crossed by a transversal, notice in this figure down here we have two parallel lines, right? Two parallel lines means two lines that are never going to cross each other, right? Like train tracks, right? They're completely parallel. So if I have two parallel lines like line A and B here, and they're crossed by a transversal, then alternate interior angles are congruent, right? So alternate interior angles are congruent. Also, alternate exterior angles are congruent. And finally, corresponding angles are congruent. So all those things that we learned in a couple slides ago. So let's go ahead and label our angles 1 through 8. So let's talk first about the alternate interior angles. So remember, interior means on the inside of the parallel lines, and alternate means they jump across that transversal on opposite sides of it. So in this case, 2 and 7, right, are alternate interior angles, and they are congruent, meaning they have the same angle measure. And if you look at these two lines, I'm looking at them, and I see this one is a little bit past like how a wall would be to a floor. So it's a little bit larger than 90 degrees. And then when I look at angle 7, I can tell that it's also a little bit larger than 90 degrees, and they look the same because in fact they are the same measure. And another pair of alternate interior angles are angles 4 and 5. They are congruent. They have the same angle measure. So whatever angle 4 measures, that's what angle 5 is going to equal. And whatever angle 2 equals, that's what angle 7 is going to equal. Next, we can talk about alternate exterior angles being congruent. So in this case, angle 1 and angle 8 are alternate exterior angles, and they are congruent. They have the same measure. So you can kind of look at the picture again, and when I look at this angle, it does look about the same size as this one. In fact, they are equal. They're guaranteed to be as long as lines A and B are parallel. That's not the only pair of alternate exterior angles we have in this figure. Angles 3 and 6 are also alternate exterior angles, and they have the same measure. Okay, finally and last, we're going to talk about corresponding angles being congruent. So in this figure, 1 and 5 are corresponding angles. They're in the same relative position to their line and transversal. And notice how they have the same measure. If I pulled this line over here, it would match right on top of the other one. They'd be the exact same angle measure. 4 and 8 are corresponding angles. They're congruent. 2 and 6 are congruent because they're corresponding angles. And then finally 3 and 7 are congruent because they're corresponding angles. They're also congruent for other reasons. Remember, we talked about vertical angles being congruent. Notice how angle 1 and 4 are vertical angles. Don't look at this right-hand side of the figure. Just concentrate on A crossing this line C right here in these 4 angles. And 1 and 4 are formed by two intersecting lines, right, that are non-adjacent. They jump across from each other. And so are 2 and 3. And the same over here when we look at line B crossing line C. 5 and 8 are vertical angles, and 7 and 6 are vertical angles. So let's kind of summarize that a little bit without having to use all the words. So you can memorize the name of all those theorems, and in many of your quizzes and your final exam, they may require you to know why these two angles are congruent, and you'd have to say because they're alternate exterior angles, and alternate exterior angles are congruent. But I like to kind of just look at the picture. And when I'm looking at a picture like this, and I'm told that I have vertical lines, right? Everywhere where I've marked an X here, those angles are going to be equal to each other. So all of the X's are congruent. Everywhere here I've placed a Y, all of those angles are congruent. Now, any time that we add an X and a Y together, we get 180 degrees. Notice that this x and this y, in fact, form a linear pair. And as we discussed before, linear pairs add up to 180 degrees. All right, so in this case, they don't even have to be a linear pair given the parallel lines. If it's an x and a y in the relative positions, when I add them together, I'm going to get 180. So another way to think about it, and this is a kind of a really crude, but it works when you're given an accurate drawing, right, is that if the angles look like they're equal, they are equal. If they don't look like they're equal, then they add up to 180. All right, that works when we are told that we have parallel lines cut by a transversal. So sometimes you have to be careful when the textbook or other mathematicians or on your exams, when they give you two lines and they don't tell you they're parallel. Then you can't make the assumptions that we just said, right? But if you're told that we have parallel lines, then all you have to do is look at the figure, and if they look like they're equal, they are, and if they don't, they add up to 180. So let's practice. What is the value of x in this figure? So take a look at my hint. You're going to ask yourself, are the angles equal or do they add to 180? That's the only question you should really asking yourself, because it's one or the other, right? We're told we have parallel lines. We can see they're being cut by a transversal C. We're asked to find the measure of this angle x, and we're given one of the angles in the figure. So the way I do is I just kind of look at the picture and I ask myself, do those angles look like they're the same measure? And if they don't, then I know that they add up to 180. So take a look at the angle measure 82 degrees here. Notice that it is a little bit less than 90. So I like to think of a 90-degree angle. So at the screen, the computer screen you're looking at, look at how the side, the side on the left and the side on the bottom form like they're a wall touching a floor. That angle is 90 degrees. So when you have that squared off figure there, 90 degrees. Right, so I'll draw the picture. Right? So in this case, remember what a 90-degree angle looks like. So that's kind of where I start. So up here, for example, on this slide, right here in the upper left-hand corner, we have a cornered off square there. That is a 90-degree angle. All right. In fact, all of these in the right in the corners form 90-degree angles. So I kind of have that mental picture in my mind. Then I look at the angle given, and I kind of ask myself, is it more than that or less than that? Is it closed tighter than that or opened wider than that? And in this case, we can see 82 is a little is smaller than 92, because if it was a 90-degree angle, this line would go straight down like I'm drawing here. So we can see that this angle is less than that. It's closed more. Now when I look at angle x, the angle that it's asking us to figure out, I kind of think about the same way. I kind of think of the same picture in my mind. I'm asking myself, is that angle larger than 90 degrees or less than 90 degrees? And I have that image of a 90-degree angle in my head. And so in this case, a 90-degree angle would look like this, right? It would go straight up from that vertex and then can touch that line. So I can see that this angle here is opened up wider than 90 degrees. Well, if this angle over here is 82 and it's smaller than 90 degrees, and I know this one's larger than 90 degrees, then clearly they're not equal. And if the angles aren't equal, right, then we know that they're going to add up to 180. All right, so we're trying to figure out a number now that when I add it to 82 gives me 180. So the easiest way to do that is take 180 and subtract 82. All right, and when you do that in this case, you get 98. All right, so in this case, we know that angle x is equal to 98 degrees. And that's what that little symbol, that little circle on top means. We read that as degrees, right? Because that's how we measure an angle. So if they had asked me, for example, let's keep this problem and let's ask for angle y, for example. There's two ways to solve it. One would be to look at the picture and look at the angles and say they both are smaller than 90 degrees. They look like they're the same, so they are the same, so y is 82. And then that is, exactly what our theorem said, our alternate interior angle theorem, right? Because 82 and y in this case would be called alternate interior angles. And the theorem states that when we have parallel lines, alternate interior angles are congruent. So if this angle is 82 degrees, this angle is 82 degrees. So now let's take a look when we have a variable as part of the angle measurement itself. So I'm looking at another pair of parallel lines. So we're told that A and B are parallel, and they're cut by the transversal C. And the question is, let's find the value of y. What is the value of y in this equation? All right, so in this diagram, is what I'm going to have to do to solve it is write an equation. So I have to decide though, are these two angles equal to each other or do they add up to 180? So I always start there when I ask myself the question, is this angle here and this angle here, do they look like they're the same or do they look like they're different? So clearly the one that's marked 103 degrees is larger than 90, and we can see that it is, but take a look at this angle where 2y plus 7 is marked. This angle right here is closed down smaller than 90 degrees, right? A 90-degree angle would have shot up here, okay? So in this case, I know they're not equal. So now I know that they add up to 180 degrees. So we need to write an equation now that will allow us to solve for y. And the equation that we're going to write is that 2y plus 7, because this entire angle is 2y plus 7. So that's why I have this part of the equation in red. That's from that angle. If I add it to the other angle, which is 103, then I get 180 degrees. So you can see that we write the equation 2y plus 7 plus 1, 3, plus 1, 3 is equal to 180. Now we can just go ahead and solve our linear equation. So we get that 2y plus 110 is equal to 180. We subtract 110 from both sides, so 2y equals 70. Then we divide both sides by 2. So we're just solving for y using inverse operations, solving a linear equation. And you'll see that when you take geometry in the future, a lot of times it comes down to setting up an equation like this and then solving using inverse operations. So that's about the most algebra you do when you're solving these geometry problems, is solving a linear equation. All right, so that concludes today's lesson on angles and parallel lines. I would go back to this slide here. I'm going to go back to this slide, and I want to make sure that you copy this in your notes because it's going to be the one that is the most useful for you. Is where we have the slide that has the x's and the y's and showing you what angles are equal. All right, so in this case we were told what alternate interior angles are, what alternate exterior angles are, what corresponding angles were, what vertical angles were. Remember, vertical angles are equal. Which angles are congruent by the properties of parallel lines. And then this slide here, right? I need you to know that wherever I've marked an X here, they're congruent. Wherever I've marked a Y, they're congruent. And then an X and a Y always add up to 180. So this is the slide here that will be most useful when solving these problems. Again, if you did not attend the live synchronous session, you need to go onto your course announcements and click on, fill out, and submit the Google form for asynchronous question 6.